All right, let's just jump right in. What if I told you there's a way to use math to get a glimpse of the future? No, I'm not talking about a crystal ball. I'm talking about probability. It's a really cool technique called Monte Carlo simulation, and by the time we're done here, you're going to get how it lets us peek around the corner of uncertainty.
I know, it sounds like something straight out of a sci-fi movie, doesn't it? A chance to see what might happen next? Well, in a way, that's exactly the kind of power this technique gives us. It's really a tool for navigating uncertainty and just making smarter decisions when the path ahead is, well, fuzzy.
So here it is, the formal definition. But what does that really mean? At its heart, a Monte Carlo simulation is just a way to understand all the potential results of something you can't easily predict, all because of random variables. Think about launching a new product or investing in the stock market, or even just planning a huge project. In all those cases where pure chance can totally mess things up, this is the tool you'd want in your back pocket.
To really get our heads around this, we're going to break it down and tackle three pretty straightforward questions. How do these simulations actually work? Who in the world used them? And maybe most importantly, how could you run one yourself? So, let's get into it. First up, how do they work? Well, the secret sauce, if you will, is something called random sampling. Instead of trying to account for every single possible thing that could ever happen, which, let's be honest, is usually impossible, Monte Carlo simulations take a much, much smarter approach. I love this comparison because it makes it so clear. Imagine you want to figure out the odds of rolling a 7 with 2 dice. The brute force way would be to, literally roll the dice thousands and thousands of times. The Monte Carlo method is way more clever. Instead of actually rolling, it builds a simple computer model of the dice and then just tells the computer to roll them thousands of times in a split second. By simulating these random rolls over and over, it builds a picture of what's most likely to happen without any of the real-world hassle. And this number right here, this is why brute force is so tough. To get a decent sample size for our dice example, you might have to roll them 36,000 times. I mean, who has time for that? Monte Carlo simulations save us all that manual labor. We can run tens of thousands of rolls in a blink. The key here is speed and scale, which lets us analyze problems way more complex than just a pair of dice.
So who actually uses this powerful technique? Well, as you can see, the answer is kind of surprising. It ranges all the way from Wall Street finance to your daily Wordle puzzle. Seriously, it's not just for statisticians in a lab somewhere.
Its most famous home is definitely in finance, for things like portfolio management and investment planning, helping people see how their money might do under different market conditions. But just look at this list. It's used in medicine, in astrophysics, and my personal favorite, it can even help you figure out the best starting word for today's Wordle. From Wall Street to your phone screen, the underlying logic is exactly the same. Okay, so that brings us to our last big question. This all sounds fantastic, but how do you actually do it? Turns out, it's not as crazy complicated as you might think. It really just boils down to a simple 3-step blueprint. It's really just 3 steps. First, you set up your model. So for a project timeline, that means identifying your final deadline and all the little tasks that affect it. Second, you specify the probabilities. You might guess one task could take anywhere from, say, 3 to 7 days. You define that range. And third, you run the simulation. The computer just repeatedly plugs in random values for each task. One run it's 3 days, the next it's 6, then 4, and after thousands of these runs, you get a really clear picture of the most likely completion dates. And the more times you run it, the more accurate it gets. So after all that, what's the one thing you should really walk away with? What's the ultimate goal of a Monte Carlo simulation? It's not about finding one single correct answer about the future. And this quote from our source material just says it perfectly. It's about understanding the possibilities that the future holds. It gives you a distribution, a map of what's most likely, what's less likely, and what's a total long shot. It's all about replacing a single, fragile prediction with a much more robust understanding of the whole range of what could be. And that leaves us with one final thought to chew on. Whether it's thinking about a career change, a big financial goal, or even just planning a huge event, you have to ask yourself, what uncertain part of your life would you want to simulate first? It's a pretty powerful question when you think about it.